Everyone. Welcome all of you to the BSE 534 Legislation Aspects of Fire Safety Management. Uh, Regardless of the super typhoon Rasaga, I think some of you may go to the supermarket to buy things reserved at home. Anyway, welcome all of you to the class tonight, and I will go to talk about lecture 3, the last part, examples of performance-based fire safety design for means of escape first. And then we will cover lecture 4, which is the second part of the performance-based fire code. Okay. And for the group formation, I have already received many groups, and about 12 to 15 students haven't yet formed groups. So in case if you are one of them, please let me know by tonight. Okay. And if not, I will randomly assign group members to you. Okay. Thank you. Now, to share the screen. Okay. By the way, can students access to the Zoom recording at the website at the Blackboard? Okay, so we can access to the Zoom and cloud recording either by this way, or you can access through the link that I provided to you. Okay, I think you need to enter your student net ID and then the password, okay, to get the recording. So if in case you have any questions, please feel free to let me know. I've also uploaded the BS British Standard 9999, okay, 49, okay, to NXH to the Blackboard for your information. Okay, so as mentioned, this is very useful reference, okay, for the fire safety manual, okay, and also some of the contents of the fire safety manual. So fire safety manual is provided for the worker or the officers to contain some information about design and operational records. So it's have full description of assumptions made and the philosophy based on the fire safety design of the building or the premises, okay, regarding the management, housekeeping, and other management functions. Okay, so what is meant by fire safety planning? Their construction and system design in the buildings are explained. So it is kind of documentation that allowed the people to look into at the design stage to describe various fire action system and fire protection systems for different incidents. Okay, responsibility of the management and staff is also marked in the manual. Okay, and updated records, continuous update records of all aspects of buildings are also included. Okay, so action taken by the management team, fire action plan, for example, what are the firefighting equipments, what are the details of interaction between security and management, etc. Okay, will be included. Okay, so you can print a copy for your reference. As mentioned, I will start with lecture 3 on the example at the back. Slide 105. So in this example, we will try to look into the performance-based fire safety design with respect to the means of escape. That means the way we evacuate. Now, you notice that in the flow chart, Let me see. We may try to determine the occupant load by the area of the premises and the occupational load factor. Remember, for office building, for example, we have 9 meters square per person. We have 9 meters square per person. So we try to determine the number of occupants, 9 meters square per person or per people for office. For example, okay, so we need to determine how many people is located in the building. And we try to identify the proposed number of location and the width of the exits. In the prescriptive code, okay, we need to know the usage of the building and characteristic of the occupants and number of them by identifying the area of the premises or the floor, and then the usage, which determine the number of people, and the width of the exit will be defined, okay? If you remember, I just have a quick look at the code of practice for fire safety in buildings. Okay, we have this booklet and we identify the usage. And then we determine the number of exits and their widths. So this table B1 in page 25 of the FS code, office 9 meters square per person is under this table. You can define it, okay? And after that, you may need to identify the number of exits and their width, okay? Remember B2, table B2, we have mentioned it in last lecture in page 34 of the booklet, Code of Practice. 4 to 30 is one exit. 31 and up to 200 is two minimum exit door and exit route. Okay, and the width is identified as below. Okay, so you need to identify the number of exit and their widths. Okay, check exit operation. Try to see if they are blocked or not, okay or not. Okay, if it is locked or if it is not properly designed, we need to modify the design and then identify the performance required and also the time for the people to become life-threatening. Okay, that means the available time for them to evacuate or the time for the condition to become life-threatening. Okay, that's still the conditions inside the corridor or inside the premises is still suitable for the occupant to stay in. Okay, if then we determine the occupant load again, propose number, location, and width of exit, check exit operation. Now, if it is yes, it is okay. Determine modeled evacuation time. Try to simulate by entering the occupant, for example, entering the occupant at the corner of the room and see how long they need to evacuate from a particular room to the nearest exit door, okay? And is the performance acceptable? If no, then modify design again. If yes, okay, we will try to have the performance being achieved, okay? Now, the TEVSF smaller than TLT is referring actually to this with the calculated evacuation time measured from the ignition of the fire. And we have a safety factor, okay, which should be less than the time for condition become life-threatening. Again, from the measures from ignition, okay? So we need to see, for example, for 1,000 occupant people, the number for evacuation should be times the safety factor should be less than the condition become life-threatening. For example, they required 5 minutes for evacuation times a certain safety factor, not sure, for example, safety factor 0.8 or 1.2, depending on different situation, then we will have, should be less than a certain value. For example, if we take 10 minutes to become life-threatening, okay, we may be able to achieve a safe design, okay? This is just a random factor to be noted. Now, further, the time from alarm until the occupant make decision to respond is the T0. And before that, we have the time from detection until the alarm is sounded, TA. A stands for alarm. TD, from alarm, okay? Before alarm, we have the ignition until the detection of fire. We have TD, which stands for detection, okay? So we try to have detection time, alarm time, the occupant response time, decision time, okay? And time for occupant to investigate the fire, I, to check whether it is a real fire, and travel time. So they take actions to start evacuating. So the time for travel. So all these 5 times, okay, are called the evacuation time in total. Now, the safety factor, SF, is too suggested for abled person to deal with uncertainty. Larger factor will be needed for young, old, disabled person. Okay. So it is supposed that we need a larger safety factor. Okay, safety factor are different from different types of or characteristics of people. For example, the elderly have lower mobility, need to have a larger factor to be multiplied, okay, in order to cater to see whether they can evacuate within the time of condition to become life-threatening, okay. For example, if 5 minutes, okay, we have 2 factor equal to 2 is already equal to 10 minutes. Okay, so we may reduce or consider 1,000 people is too many, maybe 800. Okay, 800 to be lowered. The number of occupants to be lowered. Okay, now next, number of occupants will affect the design. Table of occupant density are given in Fire Safety Annex Appendix A. That is the occupant load factor, OLF, which is similar to table B1 of the FS code. Okay, escape route geometry. Okay, what is the evacuation route? Number of exits, number of escape routes, any dead end situation should be avoided. Okay, dead end, only one evacuation route. For example, there are different rooms, okay, but this is the dead end, which should be eliminated, should be avoided, okay. But make sure there is a door available unless exit is provided. Okay. Separation of the exit, considering the travel distance or the separation distance, exit width, okay, is it 1.05 meter or 1.2 meter wide? The travel time, okay, this is also important. Now, for the travel time, actually, we will consider it as the length of travel in meter and the transverse time. For example, we call it TT, okay? Length of travel is L, and then we have T transverse, TR, okay? Whereas TR is equal to LT over S, okay? Which is the length of travel divided by the speed, okay? Travel speed relationship between travel speed S and the density of occupant. We have another equation, S equal to KT times 1 minus 0.266 D naught. Okay, density of occupant per unit area is D naught. D naught greater than 0.5 person per meter square. And we have KT equal to 84 for level corridor or doorway. And KT will increase in value if we have length of stair, fret, and riser. Okay, we have the staircase, we have the fret and riser, which is different depending on, okay, we have the riser, which is vertical, the fret, okay, which is the deep depth of the steps, okay, for each step to the power 0.5 for the stairs. Okay, so we notice that there's different characteristic of the pathway. Okay. KT itself is a constant, depending on the condition of the corridor or the steps, okay? It will change in value, okay? For example, KT is a constant equal to 84 if it is leveled corridor or doorways. If it is 51.8, it can be different length of steps. Or now for the specific flow, people per minute per meter, Fs is called a specific flow. So it is S, which is the speed of movement. Speed of movement. And usually we have meter per minute. Distance over time is speed or velocity. D naught, as we've mentioned earlier, is the density. Density, people per meter square. Now, effective width of the stairway or door, WE, is equal to the door width minus boundary layer width, okay? Or sometimes we have 2B because we have one side as B, two sides as B2B, okay, on each side. And we also considered actual flow of people, FA is equal to the specific flow times the effective width of the stairway, okay, which is in fact given the people per minute. And Fs is specific flow, as mentioned earlier, is people per minute per meter. Okay. And WE is width, effective width. Okay. So the meter is cancelled out and become people per minute, which is this unit for FA. Now the time for a number of people N to pass through the stairway or door is TTS. N is the number of people divided by FA, which is the actual flow, So the people divided by people per minute. So we have minutes as final one. This will be in minute. Okay. Because N is unit of people, FA is people per minute, okay, in people per minute. So the people is cancelled out, and then you have the minute as the unit for TTS. Now the time reach the life-threatening conditions is the time when certain tenability limits are exceeded. So tenability limits, we may consider convective heat, smoke obscuration, toxicity, and radiative. For the convective heat, okay, as one of the tenability limits, we notice that the relative gas layer, hot gas layer especially, should not exceed 65 degrees as PERSA 9088 mentioned. It is time to incapacitation for 30 minutes of exposure. So if it is too hot, the occupants cannot withstand the high temperature, and they may cause themselves to be fainted, okay, incapacitation, okay, not being able to function properly as usual. The second one is smoke obscuration, optical density, not greater than 0.5 per meter. Okay, it's Towerson in 1988 again. So the smoke may affect the visibility of the occupant. So it is considering the optical density should not be greater than 0.5 per meter. Toxicity, 30 minutes of exposure, carbon monoxide, not greater than 1,400 parts per million, ppm. And HCN, hydrogen cyanide, not greater than 80 ppm. Oxygen, not less than 12%. Because, as you know, in ordinary air with composition of oxygen is about 21% or 20.9. Okay, if it is too low, the concentration is too low, people will get suffocated. They cannot breathe. Okay, and they will got fainted and unconsciousness. CO2 not greater than 5%. Higher CO2 may also affect the, say, the blood to accept or absorb oxygen, which is also dangerous. So we have toxicity, radiative from upper layer, that is the hot smoke layer. 2.5 kilowatt per meter square should be noted. Yeah. So the time to certain tenability limits are exceeded. Okay. As mentioned, if it is 10 minutes, as mentioned earlier, we should make sure that the evacuation and safety factor, the product of them should be less than 10 minutes TLT. Okay. Of course, if it is 8 minutes, it should be lowered. Okay, the TEV and SF should be lowered. Now, let's take a practical example with the geometry of the layout. Okay, this is a 100 square meter area, assuming 0.9 person per meter square. Okay, and each side is 10 meter. Okay, so a total travel distance of 20 meter is resulted. We have exit clear opening with 1,000 mm, protected or safe path 1.2 meter or 1,200 meter, clear opening 100 mm. Now, given a room with known occupant load, which is the area times the occupant density, density. Okay. Which later you will notice that the area, and this is 0.9 is the density, occupant density. We have 90 people in this area. Okay. Given the area, given each person, or 0.9 person per meter square will be resulted. And the dimension shown in figure, calculate the time for occupant to evacuate the room and the time to evacuate protected staircase, compare the time to reach the life-threatening conditions. Okay, so we have several parts to find. Time for occupant to evacuate from room, time to evacuate protected stairs, compare the time to reach life-threatening conditions. Length of room is 10 meter, width of room is 10 meter. Length of protected staircase is also 10 meter. We assume that here we have another 10 meter. And floor area of the room is 10 times 10, which is 100 meters square. Density from the table, or is given in the information, is 0.9 person per meter square. So in some of the calculation, you can also see, if you multiply it together, the units will be cancelled out and then leave you with the number of occupant people. Okay. Now KT factor 84. 84, we are considering level corridor or doorways as in previous slides. Here, this one. Okay. And we have travel speed S is equal to KT 1 minus 0.266 D naught. Okay. If you substitute the variables, the values of the variables, you may notice the S is equal to 63.9 meter per minute. Okay. Now KT is 84. 1 minus 0.266 D naught. D naught is 0.9 person or people per meter square. Okay, and you try to have your calculator with you. Length of escape route, furthest point is 20 meter. Okay, we are not considering the diagonal, but we just consider the length plus the width of the room. The longest, okay, the farthest. Transversal time, okay. TTR is equal to LT divided by S is 0.31 minutes. Okay. Length times divided by travel speed is the time, okay, or the other way around. Speed is equal to the length or distance divided by time. Okay. Since, okay, so the transverse time is this one. Detection time, it is assumed or calculated, okay, by assumption. Assume. Either calculate or assume depends on which type of detectors. Okay, and we may have alarm time. Alarm time, we guess it. Occupant decision time, about half a minute. Okay, and investigation time, another half a minute. So evacuation start at 1.9 minutes, which is actually around 0.75, which is the TD, plus 0.1, which is alarm time, plus 0.5, which is the T occupant, and other 0.5, which is the investigation. Okay, so it is about 1.85. That is 1.9 minutes. Okay, so TD is from the previous slide. TD 0.75 minutes. 0.1 is here, 0.2, 0.5, 0.5. Okay, so the total is 1.9 minutes, which round off 1.9 minutes. Okay, next slide. Time for the last person to reach exit B is 2.2 minutes. So it is 1.9 plus 0.31 transversal time. 0.9 plus 0.31. 1.9, sorry. 1.9 plus 0.31, which is around 2.2. And curing effect, that means one stand behind another, curing for evacuation, curing for buying food, etc. At the doorway must first be considered with the width of the door. We have the boundary layer, 0.15, okay, which is B. Effective width is 1 minus 0.15 on each side. Okay, so two of them, 0.7. Okay, so specific flow through the door, specific flow if Fs, okay, through the door is 63.9 times 0.9, which is around 57.5 people per minute per meter. Okay. 60, which is actually S times D naught. D naught. Okay. 63 point, which is the travel speed. This one times 0.9. Okay. 0.9 is the D naught. D naught is occupant density. We have the people per minute per meter. Now, this specific flow through door is further, this one, further multiply with effective width, WE, which is this one, WE. Not we, but W small subscript E, okay? And we have 40.3 people per minute per minute, because this is the actual flow. This is 57.5 people per minute per meter. Okay, people per minute per meter times WE. So the actual flow is people per minute. This should be erased, okay, because the width is multiplied. So no more meter per meter. Now the time to travel through exit B is 90 divided by 40.3. 40.3 is actual flow. 90 is the number of occupant in total. Remember, 100 times 0.9 is 90, so it's 2.2 minutes. The last person enter exit B is 2.2 minutes after the first person enter exit B. Therefore, the evacuation time is 1.9 minutes plus 2.2, which is around 4.1 minutes. Okay, so 1.9 as previously mentioned here, plus 2.2 is equal to 4.1. Okay, because the first person evacuate and then it takes 2.2 2 meters for the last person to evacuate. So the total evacuation time is 4.1 minutes. Design time to escape is 2.0 times 4.1 is equal to 8.2. Okay, design time to escape, and design is okay if the design time is less than the untenable limits in the room to be exceeded. Okay. So this is an example on how the performance-based fire safety design is used to consider the means of escape, the evacuation time. So the most important things is that the design time should be less than the time for untenable limit in the room to be exceeded. Okay. So if this theater allowed the occupant to remain here until the tenability limit, as mentioned earlier, the tenability limit may include several factors. Where is it? It may include the convective heat, the smoke obscuration, amount of smoke obscured the wheel site of the occupant, toxicity, where you breathe in the toxic gas, radiative, high temperature. Okay, all this should not exceed the evacuation time should not exceed this tenability limit, okay, to be reached. Okay, any questions? Any questions? If not at the moment, we will move to lecture 4. Okay, lecture 4, reference to Professor Lu's slides, which in fact will describe the performance-based fire code. Now, in the several parts, introduction, history of the performance-based design, and the application of performance-based design in Hong Kong. And we have reference to the FS code, which is the Buildings Department Code of Practice for Safety in Buildings. And another FSI code is the Red Book, the Code of Practice for Minimum Fire Service Installations in Hong Kong. So the first one, what is performance-based code? And in fact, you will notice that the performance-based design is different from the prescriptive design. Okay, and we may have codes to follow, and in fact, a part on guidelines on fire safety, Part G, the 7th part, have been issued to allow the designer or engineers to follow on how to have the engineering approach. Sometimes we call it FEA, Fire Engineering Approach. Engineering approach. FEA. And we may also consider as performance-based fire code. Okay, performance-based design, PBD. Okay. Now for the framework, if you still remember last time we mentioned about the objectives as the top or the tip of the triangle. And then we have some functional statements and performance requirements. And after that, we have the prescriptive and the alternative solution, which is the engineering approach, okay, as from the building ordinance, regulations, and code of practice to be carried out as framework of the fire safety design in buildings in Hong Kong. Now, fire regulations and code of practice were driven by accidents and disasters, usually. And the prescriptive requirements change after a very serious fire disaster occurred. So the cook requirement getting stranger and stranger over time. Stranger, that means tighten, more difficult to pass, okay? Tighten, okay? So the tighter or the stringent the cooks be, the more difficult, hopefully, the accidents will occur and that damage will in turn will be lessened. Now, the core of practice or cook requirement are lag behind the new technology and development. Performance-based design gives a shortcut of applying the new method and also new technology to fire safety design. Now, new method and new application will become the new cook's requirement and also some of the new statements or clauses. And there are many cases. For example, the open kitchen design is a classic case in Hong Kong. So the clause, for example, C13.4 in the FRC, fire resisting code of practice, is the open kitchen for open kitchen. And the first open kitchen development was back in 2005. Performance-based design and approved by the Fire Safety Committee. After that, many developments followed and the requirements were changing. The clause C13.4 included all the changes and was a record of the development in these many years. Okay. And you can see that the fire science research result and also practical experience. Okay, so sometimes the research study have experiments should be done, and we need to set the criteria, the conditions, the environment to be to a certain standard and carry out the test and the experiment. And practical experience are also important to be included because for example, the firefighter go into the fire scenery and get some experience to share, okay, is also important. Fire regulation and cooks, okay. We may have stringent, tighter regulations after accidents happen, okay. And fire safety design is also resulted from the above, okay. Result from research, practical experience, fire regulations, etc. And the fire safety design will also give feedback to the experiment and experience. The most effective application is the performance-based design method, PBD, performance-based design. Now here shows description on prescriptive or performance-based. For example, location A and location B are of 3 kilometers apart. So you are going from location A to location B to meet someone. So in prescriptive approach, just walk with an average speed of 4 kilometers per hour. If it's younger, we may have 5 kilometers per hour. Okay, so shorter time will be resulted. If it is elderly, you may need more time. That means each hour you walk shorter distance and take longer time to reach location B. How about performance approach? If it is performance approach, you may ask, why don't want to get up early so that we can get there earlier? Want to buy a coffee on the way, so it may be somewhere to the coffee shop and then go back. So there may be some variations. Case by case study. Okay, it may be different from all different people. Okay, undergoing the walk from location A to B. How about taking a public transportation? Someone suggest to take a bus or metro or MTR or etc. Walking test for you, an estimated model will be suitable. So there may be different means of travel or different approach, and even buy a coffee at the location. So it will affect, it is not just a constant speed, which have a fixed distance and fixed time for arrival. Now, for the fire performance-based design or performance-based design engine approach, we may have some data taken, for example, the earthquake engineering, whether we have the shake table tests or the FEM tools, the fire engineering model tools, to be considered, which may affect the design considerations. In prescriptive design, we may just follow a standard curve. Okay, ISO 834, for example, standard fire test, which will, under a certain test condition, what is the effect on the column to be heated or weighted, okay, to be tested. Now, here shows the PBD using shake table test for earthquake performance. Let me see if I can play it. See, the building is under a model to have the shaking earthquake shake table test placed on the table, okay, and is shaking to see whether it collapsed or not. So it is having real experimental data and see what is the limit or the tenability of the or stability of the building to be tested under certain conditions. Okay, higher earthquake or easier ones will be considered. So it is under different conditions. Now, contributions to the development of the performance-based design. For the engineering performance-based code, actually, we have three parties, okay? The regulator who are controlling the building, have the power to control the building, and formation of the code regulations. Practitioners and owners who pay for the building and employ fire professionals to use the code for the design. Fire researcher know the scientific background and some updated or up-to-date research and development engineering tools. Okay, so in between they have some communication, okay, between the regulator and the owner for industrial practice or practical views as well as economical benefits. Whereas the researcher and the owner will also have some communication, technology input and review on the performance-based code. They use the code by the engineer or the owner. How about the researcher and the regulator? They may also exchange information on policy development and technical or technology advancement to seek continuous improvement. As the technology advance, the researcher, fire researcher or scientists may have more up-to-date development in research, which may help the regulator to form the codes. Of course, the regulator will also formulate and amend the codes from time to time. Now, performance-based design for fire safety engineering. We have different stages of fire from its ignition, growth, fully developed, and decay stages. Okay. Well, sometimes we consider this flashover as the tip of the heat release rate. And sometimes we consider the slippery slope, okay, which give the heat at the steepest to be the flashover. So in the pre-flashover, that means before flashover occur, we will detect the fire, we control the smoke, avoid suffocation and visibility to be affected, encourage evacuation of the occupant. Whereas the post-flashover, after post-flashover occur, after. This is before. Okay, you should have known this. Structural integrity, fire resistance, compartmentation, whether the compartment or the wall will collapse or the column or the beam will fall down or not. Okay, the structural integrity. Means of access. These are for the firemen who go into the site, fire scenery to rescue people and try to fight the fire, put out the fire. Compartmentation also. Okay, try to ensure the smaller rooms will not fall down or collapse. Use of PBD, we also consider the stress and strength interference model. Okay, well, this is just for reference. So you know there may be some equations for the stress, random stress and the fixed strength. Okay, and random stress and random strength of the load. Okay, strength, stress and strength interference model. And depends on the temperature, the random stress will change, okay, according to probability. The probability will change the strength. And useful formulation, defined random variable is having Ez equal to R minus S. R, as mentioned, is the random strength minus the random stress. Okay. This is random strength. This is the random stress. Okay, and can be rewritten. Okay, so this is considered with a different relationship between the strength and strength of the elements. Now, history of the performance-based design for FSE. Okay, we noticed that the fire engine approach. Okay, I've mentioned that another name for performance-based design is fire engine approach, FEA. Fire science has long history. In fact, it is out of some knowledge to review, just like to focus the history of fire engineering or the performance-based design. Professor W.K. Chow, in fact, is a pioneer of fire science and fire engineering and performance-based design in this region also. So he involves in early 1990s and late 1980s. In fact, around the world, pioneer Professor Margaret Law in United Kingdom in the early 80s was the first person. Okay, she had passed away already. First person using fire science and her research result in BRE for fire safety design. So the first project applied the performance-based design approach is the Stansted Airport in United Kingdom. Okay, and by that time, the performance-based design did not exist. From 1980s to 1990s, okay, Beck from Australia was the first person to present the concept of performance-based design. 1989, Professor Beck led a 3-year research project, which is mainly on study of the building fire safety systems at Warren Center, which is in Sydney, University of Sydney. Now, this work established the foundation of the Australian Fire Code. okay, because it is Australian on performance-based design. So 1997, the Australian performance-based fire codes was published. And when you dive through the clouds in your charter jet and spot this silver machine, you will have no doubt that air travel has, for the first time in years, been rewarded and its own special breed of architecture. Okay, this is a statement made in the for the Stansted Airport, okay, by Foster and partner. Now, the fire performance design locally, okay, Hong Kong is the first place applying the performance-based approach for fire safety design. Two projects, okay. One project is the Hong Kong Railway Terminal, okay, out there. The other is the Hong Kong International Airport Terminal 1. Okay, 1998, it was first time to introduce the performance-based design for fire safety design of large space. Guangzhou Baiyun Airport. At the same period, concept was introduced to Taiwan, and Macau also start performance-based design approach for the Sand Casino project in 2003. Okay. And in fact, cabin and island concept was also introduced in the airport in 1998, organized a technical conference, okay, for discussion. Hong Kong Railway Terminal, okay, it's mentioned the with expansion of the station began on 1995, okay, with new concourse design. Okay, you can see the roof. It's no longer just flat roof. Okay, and Terminal 1 of Hong Kong International Airport have large area. 1998 opened. Okay, and it's very different from the old Kai Tak Airport. Okay, and the terminal building extends the concept pioneer at Stansted Airport, which is a model, okay, because that's the first one since adopting airport planner worldwide. Now, it has the characteristics of lightweight roof canopy and kept free of surface insulations. Also use natural lighting. We have glasses, lots of glasses, glazed like natural light is allowed. Integration beneath the passenger concourse and all the technical equipment for baggage handling. Okay, a different arrival and departure layer of the airport, and soaring space bathed in daylight terminal building forms a spectacular gateway to the city. Further, in Chinese, okay, 1999, we have an international conference on urban fire safety in Huangshan, Anhui province, China. And the first time the performance-based design was translated into 消防性能設計, one of the articles entitled Performance-Based Approach to Fire Safety Engineering Design of Major Projects. Okay, this is the translation. Later translate in 性能化設計 in mainland China. In Hong Kong and Taiwan, performance-based design was translated as 以表現為本的設計, 以性能為本的設計. Okay, performance, okay, can be as this one or this one. Now, Hong Kong usually or also use this, and Taiwan had changed to this one, okay, in Chinese wordings. So in fact, performance-based design started in the 1970s in Chin Wen Depot as a station, 1990s. And we also have the MTR or KCR, okay, Hong Kong Terminal Airport Express Line and Tung Chung Line, Cheung Kwan O Line, West Rail Lines, etc. So prescriptive code could not meet the engineering requirement to some extent. Okay, and you can see large atrium and different glaze-like or lateral lighting allowed it in the Hong Kong station in the 1990s. Hong Kong International Airport, 1990s, 2000, 2010, and so on. So cabin or island concept, okay? So it's kind of considering the shops as an independent cabin, okay? Who will try to have the sprinkler heads and also have the curtain wall, the wall, not curtain wall, the smoke curtain to be come down to enclose the shops and form a cabin, or having a compartment that is isolated from each other as an island. So the fire load is controlled when all the curtain is fall down. Okay, smoke extraction may be independent in each of the cabin. Evacuation, long flow sprinkler is also based on the performance-based design. Free runway system layout. This is a diagram showing the free runway. And we may also have history. Say the buildings department in 1998 issued a practice note for authorized person and registered structure engineer, PNAP. P for practice and note for authorized person, PNAP 204, which is a guide to the fire engineering approach. Now, it required alternative solutions to be equivalent to the prescriptive design approach. And what does that mean? It highlights the function and the purpose of the building or the installation, given the design should not present an unacceptable risk of fire developing or spreading. So it should ensure that it is fast, safe, okay, no acceptable risk is allowed. Occupant should have time to reach a place, sufficient time to reach a place safely without being dangerously affected by heat or smoke from fire. Fire should not spread to adjacent property. Fire or smoke should not spread beyond the compartment. Okay, the third point and the fourth point is related to others, adjacent or beyond the compartment. Firefighting personnel should be able to gain access and mount firefighting and rescue operation without undue risk to their own health. Okay, so not only the occupant, but the firefighting personnel, their health and safety is of concern. Okay. The stability, insulation, and structural integrity of the building should be ensured in a fire of specific intensity and duration. Okay, the next part is applying performance-based design in Hong Kong. So it's about an hour from the start. Let's have a break of 5 minutes, and then we will continue. Any question at the moment? If not, we will start again at 7:48. Thank you. Just in case you haven't formed a group, please send your name to me and Lei Yifan. Okay, teaching support Lei Yifan at his email 2405579R at connect.polyu.hk. Any of you haven't yet formed groups here? May I know? Already formed groups? Or if any 2 or 3 of you here have not formed groups, maybe I can group you together. Thank you. Okay, shall we start part 3, applying PBD in Hong Kong. Now for PBD, okay, we noticed that the FS code for the fire safety code in buildings by the buildings department started to develop the performance base from 2002 and take effective in 2012. And as mentioned earlier, we have part G, which is on guidelines on fast engineering. And the process is from studying and reviewing codes and give recommendations. And in fact, consultancy firm also get involved in study reports, draft the codes regulations together, and finalize the codes and regulations for use for most of the premise in case performance-based design is required. It has wide range to review and covered. Background is from overseas practice. However, not all the overseas practice are directly applied, can directly apply to local situation. And we need to base on local environment to modify, okay, the codes. And the existing codes and case studies also get reference to local and overseas cases. Okay, because some of the factors, the scenarios may be similar. Assessment of current fire safety level based on statistics of fire, qualitative risk assessment, and also the relative levels of societal risk. Okay, so this determines the fire safety level and what is the fire safety objectives, which is usually life performance, life protection, property protection, or both life and property. Risk assessment, mostly qualitative, and we will have limited quantitative requirements on risk assessment. Now, for the objectives, means of escape, of course, is important for life safety. The Buildings Ordinance enacted back in 1935. So we also have 21 years later, which have the building planning regulations. Okay, so building planning regulations is under building ordinance. It's one of the subsidiary legislation. And for the code of practice for provision of means of escape in case of fire, an aligned requirement issued back in 1959 and revised in 1996. But of course, nowadays we have the FS code, the code of practice for fire safety in buildings, to cover the MOE, okay, already. So it also noted that it is reviewed by logical reasoning with objective to provide means of escape based on life safety of the occupant within the building. As all the requirements are concerned with escape route and place of safety, and does not include property protection and other fire safety objectives. Okay, so it's mentioned in this code. It is mainly on life safety of the occupant. Now, another code of practice, which is passive design, is fire resisting construction, FRC. FRC is also a reference to the Building Ordinance Chapter 123, which again was enacted 1935, but within which building construction regulation is one of the subsidiary legislations enacted in 1956, okay, which is the same as the planning, okay, 1956, and revised in 1975. Lifts, okay, elevators, okay, enacted in 1960s, changed to lift and escalator safety ordinance. It is an independent ordinance regarding lift and escalators. Fire resisting construction were further issued in 1989 and deduce objective of inhibiting spread of fire and make sure integrity of the structural elements about life safety again within the building. Okay, so provide with sufficient fire-resisting construction within the building, the fire will be limited from spreading, inhibit from spreading. Degree of protection to the building fabric and its content other than subject fire compartment. Okay. Now the third one, besides MOE, FRC, and we have MOA, there are three we may call three good friends together governing the passive building design. Means of access, MOA. Minimum fire, active services insulation equipment, issued in 1964. We have planning regulations 41A to 41C, enacted in 1992. Okay, whereas the MOA Code of Practice is in 1989. So it is noted and obvious that objective for fire safety measures for MOA is life safety of the fire personnel and also the occupant and a degree to the fire safety personnel also as well within the subjective building. Okay, as mentioned earlier, we need to consider not only the life of us, the occupant, but also the firefighter when they rescue the people inside and fight the fire. No collapse possible. Objectives of fire safety. Okay. Code of Practice 13 revision up to September 2022. Okay. It mentioned that it target on life safety with property protection and other fire safety objectives. Okay. Facilitate firefighting are the predominant fire safety objectives. Okay. Building ordinance, chapter 123. Okay. We further considered to provide planning, design, construction of the building associated work. So not only from the construction stages, but planning stage and design stage also have to be considered. Provide provisions for rendering safe of danger buildings and lands, okay, and make provision of regular inspection and associated repairs to prevent building from becoming unsafe. Functional objectives. Functional objectives considering the provision of building fire safety measures stated in the building ordinance. It is deduced in objective from the 3 COCs, passive design, and 1 COCs on active services. But the fire service installation COC target at life protection only. Only a degree of property protection. For the others, is for life safety mainly. Experience on risk from fire. It is noted from year 1991 to year 2000, most of the fire occurred in residential buildings. And besides, we have commercial building, okay, and we have assembly and hotel and industrial premises as noted from number of fires. And for the injury, you can see that lots of them are also residential related. Residential. Okay. The deaths assembly premises is significant high. Okay, in 1997, commercial premises 1996, which refers probably to the Gali building fire. Okay, with a large yellow being observed. Now, accidental and malicious fire. Malicious fire is a fire set on purpose by some bad guys or some people. Annual average suspicious fire, 12.7%, increased from 8.5% to 13.1% from 1992 to year 2000. Okay. And within which the 5,600 reported case, residential is 10.2% already. Okay. Industrial premises, number of fire has reduced from 61 to from 1991 to year 2000. Now, how about the causes of fire? For residential fire, foodstuff, stove cooking, overcooking, okay, 2,600 around, okay, which is the highest. And for the commercial building, we may have the general electrical fault. Okay, industrial is related to fault and also careless handling and disposal of cigarette ends, matches, candles, etc. Okay, assembly is also electrical fault. Now, for the rescue committed on fire safety, in Hong Kong, the average running cost of the fire service is about 0.344% of the GDP, gross domestic product. Now, the cost of the fire protection system installation is in the order of 0.001% of GDP. Okay, it includes insurance with premium and claims in order of 0.4 to 5 GDP. And total commitment amounts to approximately 0.8, okay, commitment on fire safety expenditure, which include research, education, and fire protection prevention or fire prevention campaigns, or not accounted. Okay, so its gross amount to 0.8%. Proportion of spending fire insurance is high because high building density compared to other countries. So other countries will be 0.2 only, but we have 0.4 to 0.5 GDP. So brief summary, funding of Fire Services Department, FSD, cost of fire prevention, education campaign, cost of fire protection within building, insurance, and total approximate 0.8 GDP. Okay, so we have the total. We have different amounts being added. Now, that is the situation for Hong Kong. Now, we look at United Kingdom. For the requirements of the building regulations and expressed as functional terms in 1985. Okay, they were set out in approved document Part B, 1991. So basic objective, again, protection of life and property protection is not directly addressed. So as in the reported case, we found that drilling is also used for residential purpose or domestic purpose. Highest is residential, okay. And drillings, okay, also noted. Heat, smoke damage. And places of work, and we have comparison of arson fire, which again set on purpose, occurrence of arson. So someone set the fire intentionally. Statistics, misuse of equipment or appliances, 16%. Careless handling of hot substance, 9%. Okay, so ignition source mainly is the cooking appliances, up to 6,800 cases. Just 1/4 of all the accidental other than building fires. Electrical appliances represent 25% of that. Okay, large increase in fire, also cooking appliances is the main effect. Statistics, total cost in England and Wales is 6,000 million pounds per annum at the 1999 prices. We have the 0.63% GDP. So by comparing GDP, we can estimate the percentage with respect to the economic. It also covers domestic, commercial, public sector premises and account for the fire protection, fire safety expenditure, insurance, property loss, and we also have loss of business and fire service response. Okay. Now, the fire accident considered limited to the first ignition item or ignited item. Okay, whether it is limited to room of origin, limited to floor of origin, limited to floors, affected more floors and the whole building. Okay, multiple floor is considered in this case. Single floor has the floor of origin. So, internationally, before drafting the local FS Code of Practice 2011, review of work covered Sweden, Australia, United States of America, and Japan. They are summarized in the following slides. So we have in different countries, we have different community, different sectors of community, and different reasons to carry out and implement the fire safety measures. Some may due to, but not limited to, law compliance. Okay, of course, this is very important. Protect life of occupant and firefighter rescue team. Protect own property and content. That is the property protection. Adjoining property content, heritage building, historical structure and culture. Satisfies insurance requirement, maintain business continuity. Usually we have life protection, we have property protection, and we have business continuity as the major fire safety objectives. Parts of the fire risk management program and also protection of the corporate image, reputation, okay, reputation. It's also important. Moral obligation. Okay, for the objectives, okay, just highlight the key points and the buildings regulations and codes of practice in different countries or all the countries place life protection as the major or the primary fire safety objectives. Okay, and do not specify property content protection as primary fire safety objectives. And in Japan, okay, we mentioned protection of property of people. In Australia and US, require protection of limits to property loss. And usually, only life protection of the occupant is regulated. Okay. And we may also consider property protection of either subject building or other properties is not considered as primary aim. Again, not. How about Hong Kong? Similar to Sweden and Australia, the FSD Code makes specific reference on property protection in addition to protect life. Now, that's a summary in tables, in a table. The risk of fire or from fire is represented by a number of fires in different types of buildings. For example, residential, commercial, industrial, depending on different usage and situation. Locally in Hong Kong, the first one is people who live in domestic use, residential buildings. Secondly, we have the commercial, people work there, industrial factories and industrial undertaking, public assembly. Okay, we have the public assembly hall and concerts, theaters, hotel with sleeping risk. Okay, for others, you can see all of them are residential, having the first rank, and the most significant risk is found in residential domestic purpose. About 50% of the total fire. Whereas percentage of death, highest, UK, Hong Kong, US, Australia, and Japan. Okay. the percentage is quite high. More than half of the accidents or deaths is related to residential dwellings. Number of average annual fire deaths in million population. Okay, shown. And per 1,000 fire, okay, it's also shown. So statistic fatality per million population in these 6 places or region. We can see the deaths is increasing per million population. Okay, per million population. Fatality of residential fire and per 1,000 fire. UK, US greater than 90 and 84.5% respectively. Number of estimated deaths per 1,000 people. Okay, 7.7, 31.3 with average value from 1991 to year 2000. Okay, resources committed. The level of expenditure on fire safety, we can see that Hong Kong is one of the highest with 0.8 GDP. The cost of fire system expenditure contributes 0.125% of the 0.8% of GDP. High expenditure is also due to insurance costs. Okay, even at home, we will buy fire insurance, okay, to protect, just in case any fire happened in our home, at our homes. Now, review results. We have mentioned fire safety objective in Hong Kong and other countries, but we noticed that life protection is the prime and the basic and the first objective in building regulations. Besides, it is property protection, okay, and overall protection in some of the brigade regulations. In UK, Sweden, and Australia, property protection is not considered. It's not that important. Fire risks also are relatively low in Hong Kong, and resources committed for fire safety provisions in Hong Kong is relatively higher than other developed countries. And most requirements in the code of practice are reasonable. Okay. Besides, there are recommended general objectives for building fire safety measures. Okay. Protection of occupant, protection of firefighter, rescue team, rescue personnel. Okay, these 2 are the life. Adjoining properties and content. Okay, environment. Okay, 3 main parts. Now, part 4. Okay. Again, we have the FS Code 2011. As mentioned earlier, we have the fire safety on life and property. So for life safety, provisions are provided for life for occupant, minimize the fire spread between the compartment, prevent collapse, which provides sufficient structural stability, and facilitate firefighting and rescue by the personnel. Okay. And for property protection, okay, minimize fire spread, which is in fact quite similar items may be found fire spread between buildings, between compartments, and firefighting rescue team. Okay. This figure have been shown earlier in previous slide. I do not repeat, but you notice there are different objectives, functional statements, and performance requirements as in the code. And for the goal, okay, we also complete what is the building ordinance goal statement on fire safety before. This is a repeated slide, so we may skip it. Okay. Now, it's functional statement. Or in fact, before the functional statement, we have objectives. So I put the objectives again here as the second time, as we discussed it earlier. Functional statement, it's described in more details about the planning regulation, construction regulations. And we have the building shall be provided with means of escape in case of emergency as may be required by intended use of building. Okay, so this is mainly for MOE. MOA, FRC, construction planning. Okay, you can see at different sections. You can have more details, description. Functional statement is very long, but of course it's most focused on the resisting construction with weather collapse, weather passage of smoke and heat through the gaps, and also the temperature at the other side of the heated structure is mentioned. For planning, functional statement requirement of access staircase for fireman lifts, firefighting and rescue staircase, emergency vehicle access, EVA are mentioned. How about fire safety management? Okay. We have the code of practice for fire safety in buildings, which have a section 6 on fire safety management. So for that, it is the fire safety provision provided in the building shall be available during fire emergency, especially for the fire action considered. Now, how about deemed to comply and alternative approach? So the triangle, objective, functional statements, requirements, we have this one, some. Okay, and we have the, sorry, I draw a double line. Okay. We have deemed to comply provisions are the prescriptive code. So deemed to comply provision. Also called prescriptive code requirement. Now, there are different parts in the requirement in the code of practice. Part B to Part F are prescriptive requirement that is deemed to comply and meets the performance requirement as stated in the ordinance. Whereas alternative solution, okay, as deemed to comply or prescriptive requirement, performance-based design or fire engine approach develop alternative solution. So alternative solution is this next part on the right-hand side of the triangle. Now, approach solve the issues. Prescriptive requirements cannot provide solutions. Basically, we follow the codes, but if in case the codes cannot provide solution, we have alternative solutions. Now, PBD solutions do comply with the FS code 2011. Now here further shows the compliance in more details. Clause A 3.1. The adequacy of the provision shall be demonstrated by compliance with the performance requirement in section 2. Okay, so it comply with the deemed to comply provisions, formulate alternative solutions, and combine A and B. Now, performance requirement in regulations for MOE. Okay, we have the performance requirement B1, B2 up to B7. Okay, out of which it mentioned how the building compartment or story should provide adequate means of escape MOE to all and make sure all the occupants can evacuate safely without being hindered or overwhelmed by the effect of fire. Okay. So it is quite detailed in description of the performance. Adequate fire safety provisions, evacuating occupant, means of escape, sufficient warning, building management, and adequate signs should be provided. Escape for tall buildings should allow take short rest where the refuge floor is provided. Minimize threat of smoke through the stairs and also firefighting stages activities. Now, the guidelines part of the performance requirement further states details considering comply with B1 to B7. Okay, here are some of the examples on classification of the building. What is the use and function of the building? What is the nature, capacity, location, and awareness? Okay, these several parts is very important. Okay, their location, awareness, okay, conscious or not conscious, capacity, mobility of the occupant also is important. Okay, fire hazard, growth, potential growth duration, building height. Okay, the height also affects the number of occupants, which in turn affect the number of evacuation routes. Okay, size, layout, location of exit routes, resting area. Suitable construction prevents slipping and falling risk. Temperature, visibility, toxicity of smoke, fire service intervention. Now for the performance requirement of FRC, fire resistant construction. Okay, previously we have the MOE, MOA, and now FRC. Okay, performance requirement C1 to C number 6 on the provision and ensure adequate fire protection system is to inhibit the spread of fire, okay, which is within the building, between building and other property, allow occupant evacuate safely and provide allowed fire service intervention. Okay, means of access, MOA. We have performance requirement D1. Access staircase for firemen, fireman lift, firefighting rescue staircase, and EVA. Performance requirement of fire safety management. Make sure that they are in good condition, good working order, and evacuation procedures are effectively being carried out in case of fire. So this is an emergency mode or fire mode, okay, emergency mode. This is the normal mode of operation. So during normal situation where fire does not occur, we also need to make sure that they are in good conditions. So in case of any fire occur, they can attack the fire or suppress the fire. Okay, now we have the guidelines on fire engineering. Okay, for the guideline, let me see. It has several parts, several sections. It's up to more than 100. 102. Anyway, we will continue. Okay, otherwise I'm afraid we do not have sufficient time. Now, table of contents, you note there are 10 sections in part G, the 7th part of the FS code. In each part, they will describe the use of a particular part and also their objectives. Sorry. For example, G2.2, okay, fire engineering framework. We noticed that the fire safety objective is mainly for life protection and life safety, and functional statement on building planning regulation, means of escape, okay, for life safety. And the performance is divided into two parts, B1 to B7, as we go through that earlier, BA to BM, okay, C1 to C1, B1 to 7. And then we have prescriptive solution and alternative solution. Alternative solution is if in case prescriptive solution cannot be provided, we considered another means, alternative means to solve the problem, which is the fire engine approach. Now, G2.2 continued with the performance requirement on these three parts and fire safety management provided in Part A. And the relevant performance requirement further states that the performance requirement should be assessed against the deemed to comply provision for an alternative solution. So need to check with the Cook's requirement. And there is a checklist, okay, for each performance requirement. And there is alternative design for MOE, okay. Mentioning the building and fire compartment or story should be provided with sufficient and adequate means of escape for all the occupants evacuate safely without being overwhelmed with the effect of fire. Okay, so there should be sufficient number of staircase, there should be sufficient number of exits, and make sure that all the occupants can evacuate safely from the building in case of fire. Now here shows smaller words, but you can refer it to the code of practice directly. Guidance to the performance requirement for means of escape. It covers many parts. The use of building or classification of the building. We have the number of occupants, their characteristics, the use of classifications determine whether the occupant of the building are potentially having slipping risk, they are asleep, or they are awake, okay, they are just conscious, familiar with the building, or transient. That means they require assistance for evacuation. Okay, capacity, location, to determine the number of occupants inside the building and the number of staircase for evacuation. Okay, the travel distance, etc. We also mentioned about fire hazards, which within a certain use classification may directly impact adversely, negatively on the evacuation of the occupant and need to be considered with regard to the spread of fire, intensity of fire, and the growth rate of fire, and the smoke spread. Building height, okay, taller building, we need refuge floors to be provided. So these are some of the examples. You can read through it by yourself when you have time. And for FLC, okay, slide number 76 is for MOE. 77 is for FRC, fire resisting construction. Okay. Similarly, the classification, occupant capacity, locations, fire hazard, and growth also affect the fire resistant rating, compartmentation, and firefighting access. Okay, MOA is also considered in slide 78. Okay, you can see the fire resistance EVA. Okay, overall building size and compartmentation are also provided. Fire safety management. Use of classification of the building have impact on fire safety management required and motivation to complete maintenance. Correct maintenance. Need safe evacuation of occupant to be assisted with training. Okay, so we have the maintenance plan, we have the staff training plan, and action plan, fire action plan in case of fire. Okay, introduction to fire engineering. Okay, performance-based approach required to identify the performance requirement to demonstrate assessment. We also need to have the fire safety assessment report to illustrate how the alternative solutions are formed and detailed assessment on different aspects with respect to the building performance. We have application. Okay. Fire engineering to be adopted to formulate alternative solution where genuine difficulty in complying with the prescriptive code and attain overall level that is equivalent to which result achieved by full compliance with the code. So even though they cannot comply with the code's requirement using the prescriptive approach or prescriptive or the deemed to comply provisions, they choose alternative fire engineering approach to achieve equivalent full compliance to the deemed to comply provisions and achieve an overall safety. Safety margin and safety factor. Time-based assessment. Okay. We have the available safe egress time and the required safe egress time. So it's based on time as the base, depend on the worst credible fire, potentially worst credible fire with single system failure. Safety factor for comparative assessment, test verification, range from 1.5 to 2. Level of safety, either equivalent to the compliance of codes or safety acceptance of performance requirement. So this is the methodology. Okay, deterministic, probabilistic, and acceptance requirement. So what is meant by equivalent? Okay, show level of the fire safety comparable to the level of safety achieved. Okay, ASET and OUSET, we have the abbreviations showing available safe egress time. Usually 5 models will have the simulation and get the time, available safe egress time, where the required safe egress time is found from evacuation analysis. Okay, actual taking what is the evacuation time for the occupant to escape. Okay, the timeline. Both OUSET and ASET are measured from ignition of the fire. Okay, and then after ignition, smoke generated flame or heat. We have the detector with different detectors, smoke detectors, heat detectors, flame detectors, etc. Okay, and then we actuate the alarm. And before the alarm, that the detector sends signal to the panel and further sound the alarm and then notify the occupant to evacuate. But before their evacuation, they have the pre-evacuation. Again, the pre, that means before. They may try to search for their friends and relatives. They may ensure that it is a real fire to need to escape. they have the movement time, okay, to complete the evacuation. Okay, once they complete the evacuation, it is the required safe egress time that is measured. Whereas the available safe egress time is considered when the ignition time up to the hazardous condition, that is the tenability limit. Okay, this is the available safe egress time. So usually this available safe egress time is greater than or longer than the required safe egress time. And there is a safety factor to be considered. Okay, numerical modeling on evacuation. Let me see. You can see the occupants are evacuating. They may queue up and evacuate from the layout plan. A set to see how long it's required for the occupant to evacuate. Okay, there are some simulations results that may be used for assessing whether it is under good condition for the occupant still kept into the evacuation route. Okay, let me see. Now, next part is the fire safety subsystem. Okay. We still have quite lots of sections. I propose a break first. Okay, I propose a break first. Any questions? If not at the moment, we will start again at 8:45. Okay, thank you. Okay, shall we continue? Now, as we see from subsystem, hope that students can heard and hear the sound now. Now, subsystem 1 to 6, different subsystem have the focus. For example, we have the initiation. Oops. We have initiation, development, okay, and we consider whether the fire will occur or not, how likely it will occur, and assess with the realistic assessment of fire growth rate, fire size, rate of fire spread through the fire compartment, etc. Okay. And we further, after the fire start, we will consider the smoke generated and see how we have assess of the life safety. We may have the smoke layer height, visibility, toxicity, okay, where appropriate. Okay. And then smoke generated, we have fire detection, warning, that is alarm, and suppression. For example, the water-based system, sprinkler heads. Provision of warning to the occupant may also provide automatic suppression of the fire. Okay, subsystem number 4, we have the spread of fire, their impact and control. Okay, we may either use active fire services installation to control the fire, or we may have the fire compartmentation, which is a passive way to separate or minimize the fire spread. So other key system for control is use of suppression system, hose reel, and even extinguishers. For the subsystem number 5, occupant. Okay, as occupant, life safety is important. It required the escape of them, considering the fire detection and the occurrence of some warning cues. These warning cues may be smoke, maybe dark smoke or hot or high temperature, maybe alarm, okay, and recognition of this cue and have pre-movement activities. They may try to ensure this is a real alarm and real fire that they need to evacuate, and then movement to the evacuation place. Subsystem number 6 is fire service intervention. Intervene with the fire service department, fire officers or firefighters, and event based on methodology. Event-based methodology considered time taken for various firefighter performance to be carried out. Okay, so the fire entering design meets the performance requirements. And before that, in fact, we have the fire entering assessment. Okay, which we have the evaluation acceptance with different requirements design meets. We also need to base on some guidance, building classification and occupancy, different types of people, their characteristics, different 6 subsystem, SS1, 2, 3, 4, 5, 6 is having some input to the fire engineering assessment. Okay, number 6 section, number 6 after the fire safety subsystem as number 5. Pre-submission inquiry. Authorized person, AP, should consider implication of fire safety in the building design and also consult the building authority at an early stage so that the fire safety objective can be agreed. And we also have approval, okay, submission of the GBP. Now, this time the GBP is the general building plan. And submits the FSRS, the fire safety assessment report, together with general building plans to BA for approval. And we also have the assessment approach. For example, we have the based on assessing subsystem and the interaction, we have the timeline approach or timeline method. A set versus R set. Okay, we have the assessment method, which includes the qualitative, quantitative of the subsystem, involve all the systems, and usually quantitative analysis using the time assessment will be the most familiar and common type. For design fire, you may have fuel control, ventilation control. You may have learned this in the fire dynamic subject. And the fire curve has shown different phases of fire. Okay. Now, as mentioned, the steepest slope of the heat release rate curve should be the flashover. I agreed with this chart more. And incipient stage, it is at the start, where it's growth stage, and fully developed, which is the post-flashover stage. And we have the decay stage, okay? Decay trying to drop down. For the fire development, okay, let me see if we can see anything. It's not. Anyway, it's showing the living room, which have the ignition source at the little bin, okay, which is on fire. And further, try to ignite the solver, and then the wick chair, okay, have the flame pinch, and flame also approach the ceiling. We have the ceiling jets, which spread radially to adjacent, and the hot smoke re-entrain back to the ceiling, and also spread to ignite the table with papers on it. TV cabinet, armchair also on fire, flash over in the room. 2 minutes, 38 seconds. Okay, so the video in fact shows the fire development in the living room of apartment. Now, examples on the design fire, for example, the values 1.7 megawatts, 1.5 megawatt at hotel and commercial business facilities respectively, may be considered as case-by-case basis. And movement time, pre-movement time, and also tenability criteria. Okay, we have go through some of them. Smoke layer height and the radiant heat transfer or radiant heat flux, convective toxicity, visibility, smoke temperature is noted earlier in one of the slides. So these are some of the factors that affects the tenability limit in the apartment. Now, for fire assessment report or fire safety assessment report, we have different sections. Okay, we may introduce it. Where's the site? What is the building use classification? How the codes are being complied. If the prescriptive or deemed to comply provision are not complied with, what is the alternative solutions? And how we have the relevant performance requirement and guidance to be followed. And we also have bounding condition. Okay, bounding conditions with this list regarding the floor numbers, the occupancy, the usage, compartment limits, fire resistance rating, etc. Section number 9 and 10 is or are computer models and references. Okay. Let me see. PyroSim is another simulation. Okay, having a simulation model, simulating the one with the theater. Inputting some options, importing some parameters. Specifying file size, hit release rate. Place in 3D models. FPS file dynamic simulator input. So in fact, run the simulations. This view, okay. For example, a fire happened on stage. Geometry spread hot smoke, black smoke, spread to the balcony, and spread to the areas. Okay, so simulation models are used in pretending or simulating what is fire occur in premises, and different fire size, different view, different scenarios. Okay, components or passive building design, performance-based design in active fire services installation code of practice. Sorry. Now, there are two sections. One is on minimum fire service installations and equipment. Another code of practice is inspection, testing, maintenance. So actually, it's having two sections. There are lists of requirements for different types of building. Okay, sprinkler systems, fire, fight, gas, fixed foam, and we have sprinkler, supply tank, etc. So, for example, we try to look into the dynamic smoke extraction system, and we have the mechanical ventilation or ventilating system able to remove smoke and heat product of combustion from the fire compartment, okay, and apply fresh air so as to maintain specified smoke layer, okay. So generally, we have a room, okay, and we need to provide an entry of air at the base, okay. For the fire, we have the plume to maintain a smoke-free area. The occupants will evacuate where the air will move in, okay, and maintain the buoyancy of the hot smoke at the top, hot smoke layer, where lower layer is cool air. Smoke-free zone below the smoke layer. Okay, static smoke extraction. For static, we just consider smoke reservoir, localizing ductwork, permanent opening, automatic opening of window panel and external louvers. Okay, so as to remove the smoke or combustion products from designated compartment. Okay, so dynamic is with the mechanical fan, mechanical ventilation system. Static is just some separation. Okay, reservoir, for example, smoke curtain or some slits which try to ensure the smoke will trapped in the reservoirs. Okay, and the reservoirs not exceeding certain area, horizontal distance, aggregate area of windows may also be some of the conditions to be satisfied in order for the static smoke extraction to be provided. Required for premises for the domestic building, high rise. We have several requirements. Okay, high rise. Okay, high rise refers to the building of the height greater than 30 meters or the evacuation routes from the top to the land ground floor is 30 meters. So hydrant and hosiery is one of the requirements. Okay, the extent of requirement further, we have 7 items here. The 5th item, okay, we read through the 5th item. Sufficient hydrant and hosiery to be provided on every floor. Make sure that the 30-meter hose is covering every part of the building. Okay. Now here shows the pressure and flow rates. For the pressure is kind of energy that we have high pressure, okay, high flow. Then if you put a hand or underneath the water, it will splash, okay, and you can feel large amount of water. If you have low pressure but high flow, okay, just you can feel the amount of water, but it will not splash around, okay. But if a high pressure but low flow, inadequate amount, small jet of water, but if you put a hand here, okay, it will splash around. Low pressure, low flow, just drop of water available. So flow rate is referring to the amount of water delivered. And we further have pump heads to allow the water to be delivered from low level to high level. Say from ground floor, we have the transfer tank. We need the duty pump and standby pump to transfer the water to upper levels. Duty, standby, okay, to transfer the water to upper floors. And in some cases, if it is higher than 60 meters, the topmost hydrant over the FS inlet greater than 60 meters, then we need intermediate booster pump. Intermediate booster pump also helps to pump water or boost water upwards to higher levels. Okay. Now the pump head is usually considered with the static pipe friction and index pressure, which is the farthest and the topmost is the critical case. Hydrant, fire hydrant, for example. Okay, the pump head need to make sure that we have, for example, 350 kPa available at the hydrant minimum. Pressure. Okay, static head is how high is the building. Friction loss is how much head is lost due to the friction and pressure throughout the piping. Index pressure is the pressure at the hydrant or the hose through. As mentioned, 350 kPa is the minimum head required at the hydrant. Further requirement for high-rise domestic building, we have additional requirement. Okay, and this additional requirement considered the lining on acoustic, thermal insulation, okay, for decorative purpose and intended storage of dangerous goods. So in fact, the content based on the lecture notes by Professor Lu and also code of practice for fire safety in buildings and also the minimum fire surface installations and equipment. Okay. Any questions? So the two large booklet on code of practice is available from the website. So as I have shown in previous lectures, one of them is this one. Okay, you can check this from the web page on buildings department. Or let me see. Another code of practice is by the fire service department, under which you have fire protection, you have circular letter, code of practice, and noticed. Okay, you have the code of practice here. Okay, this one. Okay, we have go through that in previous lectures, so I do not repeat it. As I've mentioned at the early or at the start of the lecture, I've also uploaded the BS 9999 for you to have a look. Okay, 7 pages. So fire safety manual with Annex H. For the assignment, of course, I've mentioned the group formation. A student asked the print words is actually printed in PDF file, not actually submit the hard copy. No need. We have the online submission through the Turnitin in the Blackboard. Okay, so you do not need to print a file to meet. No need. Okay. For the next lecture, we will go through, let me see, the topic on human behavior. Okay, so human behavior, of course, as you know, is complicated sometimes. Okay, not only because of the characteristic of the occupant, based on their sleeping risk, they are asleep, they are unconscious after drinking alcohols, or they may have lower mobility due to wheelchair or the walking sticks, etc. But they may try to move in, say, together with their friends in a group, or they may try to search for their family members before they run away. So there are lots of factors to be considered for human behavior in evacuation. And it also affects the fire safety management. Okay, so especially in the fire action plan, how to have phase evacuation of the occupant, how to divide them into different stages of evacuation. Okay. Okay, any questions? You still have some time, 5 to 10 minutes. Oh, the clocks run faster. Okay. Let me see. Okay. So I wait for your group list for those who haven't yet formed groups, but it seems that just left about less than 10 students. So maybe forming 2 groups more. Okay, and we will release. Some student asked me to release the assignment topic earlier, but I worry about overloading of you in receiving 2 assignments at the same time. So you haven't yet handled the first one. You submit the first one, but you receive another one already. So I will see how the group formation will be. As I promised, it will be released in week 7 on 13th of October. Okay. So any other questions regarding the subject matters or the assignments? If no, maybe I do not keep you for long. Please go home safely and stay safe for tomorrow's situation with the typhoon. Okay? Thank you. Have a good night. Okay. Bye-bye.